Okay, let's get started. Good afternoon, everyone. So today we're going to be continuing on our sort of examination of sort of policy issues and how modeling systems can relate to these things. Today we're not going to look at necessarily a specific policy, but rather we're going to be thinking about equity and environmental justice, kind of in the context of policy decisions, and then ways in which systems modeling can help inform some of these ideas. Okay, so to start out with, I think there is sort of a, let's say, broad acceptance, right, of climate change and the things that we as a society need to do to kind of mitigate those effects. Um, yeah, so it's not really a question of whether it will happen, but how, right? And so we are already thinking about and have been implementing many measures to combat climate change. Um, and now I think there's an important question of like, how do we make sure that people aren't necessarily left behind by these transitions, right? Because these technology transitions, behavioral transitions, they're going to affect different populations in different ways. And so modeling can be an important tool to help measure and understand some of those impacts, as well as even to model how you can think about addressing some of these issues. Okay, so before we dive into specific examples, wanted to kind of lay the groundwork here for equity and environmental justice so that we're all kind of working in the same frame. So the environmental justice movement has been around for a long time. This is born out of inequities on the environmental side of things. So in the US specifically. So here are a couple of, I think, more prominent examples that people point to when thinking about kind of the origins of some of the environmental justice movement. So toxic PCB waste in landfills in the early 1980s. There was a fossil fuel based incinerator that was challenged by this organization called Concerned Citizens of South Central LA in the late 1980s. And then this example in New York of a river sewage treatment plant that was located in a disadvantaged, disenfranchised community in the late 1990s. So a lot of these things are kind of location-based environmental externalities and placed in areas where you have maybe lower income, disenfranchised communities that don't have the same level of resources to try and push back against the installation of some of these things, right? You can imagine that if I wanted to set up a sewage treatment plant in like the Hamptons, right, there's probably going to be a much stronger kind of pushback. And so this leads to this idea that we have systemic injustice in the way that environmental externalities are put on different populations. So those are maybe a couple like qualitative examples, but it's a statistical fact that a lot of the polluted environments are most commonly associated with people of color. So we can see this on the left-hand side here, cost and exposure. And so across different sectors, like you have like transportation here, construction, industrial, electric utilities, and then from end use in residential, cooking, agriculture, right? And so there is a disproportionate amount of particulate matter that's caused here in your sort of white or other, and relatively lower in Black and Hispanic populations, and yet in terms of the exposure, it is kind of inverse to the people who caused it, right? And so you have much higher exposure, relatively speaking, in Black and Hispanic populations. And then also there's an association with income as well. And so you can see how that kind of compares pretty consistently in terms of local air pollutants, PM 2.5. The bars for lower income are generally going to be higher in almost every category. Okay. Any questions? Yeah, so maybe you guys have seen this graphic before. So equity, so what is equity? This ensures that people receive access to the same opportunities. And so how might this apply to like climate change efforts? Everyone think of any examples where you may have programs that are either designed specifically to address equity issues or programs in climate change that may cause equity issues. Any ideas? Yeah.
For example, if there were EV subsidies that are the same for all income groups, that would improve inequity.
Yeah, and so how do they address this issue in?
Then you probably could make the subsidy based on income.
Yeah, and so in California, for example, we used to have this program called CVRP, the Clean Vehicles Rebate Program, and that was kind of a flat rebate for anyone who purchased an EV. And over time, it has evolved and changed in the way, the mechanism with which it's awarded to be based on income. So we think about these like base values of CVRP. If you're below an income threshold, then you actually can get more money. And if you are above a certain income threshold, you just don't qualify. So that's an example where, an easy example in terms of like structure, how it was changed to adapt to this kind of equity issue. What about something like a carbon tax? Okay, we've talked about carbon taxes before. Would that be considered an equitable mechanism? Yeah.
Maybe do something against it, in terms of disadvantaged communities have to utilize the kind of the lowest cost option for things, and so a lot of those things, the cheapest thing is going to be like a carbon related thing. They're going to drive less efficient cars, or they will have to consume more because of the cost aspect, and so having a tax on that would be kind of more burdensome for them, since that's their only option.
Yep. Okay.
Yeah, I think that could be the case, but I think also like richer households on average like emit more CO2, so they probably have to pay overall more, I would guess. And for example, and what I think they were planning in Germany to do that people who are low income and like are below like a certain emissions threshold, they get like some of the revenue as like a credit.
Yeah, so you guys are alluding to a similar issue, but the general idea is that when you apply a tax to some kind of good or service, what we consider, what is the term for this? A sort of necessary good or service to just kind of like provide basic living amenities, right? So we think about things like food or rent or like transportation, like gas costs. If you tax any of those things, it is generally considered to be regressive, right? So you have to spend a larger proportion of your income relative to someone who has a higher income on basic costs of living. So any tax on a basic cost of living that is uniform across income would be considered regressive. And so a carbon tax, yeah, is widely considered to be a regressive tax. And one of the proposed solutions in a carbon tax is that the money that you raise from those funds go back to like lower income individuals. And so you essentially get rebated for you get rebated for those options in order to make the program a little bit more equitable. Okay. Any questions about that or concerns? Okay. Yeah, and so even in these two examples, I think the idea is that if you look at these policies with equity in mind, oftentimes there is a way to design and structure the policy such that you kind of alleviate some of the equity concerns that might come out of a policy like that. And so these days, when we think about climate mitigation, it's really important to at least have this lens in mind, because if you don't think about these things, it's just, okay, we have this carbon tax and it's going to be economically efficient, right? You may miss the sort of implications of this in terms of like equity. Yeah.
I have an example, but I'm not sure if this would apply. So
Okay.
I'd see if we can discuss it. There's the discounted program for Fast Track. If you're part of a Bay Area county that is below a certain threshold of low income, then you get up to like 50% off, like in certain tolls.
Yeah.
But if you make that option available to low income, and that induces the behavior that's desired, which is like using public transit, less vehicle miles traveled, like more efficient way, like at large scale, but you don't do that so much for the affluent portion of the population that does like abuse the fact that does more vehicle miles traveled, like has like more access to this technology that sometimes exacerbates the problem. Like
Yep.
how does that?
Yeah. So that can happen. There's like a rebound effect when you return the money. Let me I was wondering if someone would bring that up for carbon tax. Let's think about this for a carbon tax, and then let's think about this for this particular issue, because I think it matters the way that you get the refund. So in a carbon tax, you collect all the revenues and then you just disperse some set amount back to an individual. So the idea is like let's say I have, let's say I have the option to use, what is a good example here? Well, okay, well, this is not a good example, but let's say you have the option to use like a $10 light or a $5 light that's like more, that's more efficient. Yeah, this is not a good example. The idea is that you well, okay. It's, let's say you use there's two services that could use, and one is more expensive with the carbon tax when you use that service. As an individual, just because you receive a flat check at the end of the month or the end of the year doesn't mean that I would be incentivized to be like, oh, I'm still gonna try and spend money on the more expensive thing because I get the money back, right? You still choose to use the less expensive thing after accounting for the carbon. You just still get some money back as a like remediation for in general prices being higher. But oftentimes the like price signal is the price signal for like the carbon price is intentionally kind of separated from the rebate a little bit so that the behavior piece still happens. So for example, if in this fast track example, let's say, yeah, so suppose that all of the people who get a discount get some kind of rebate at the end of the month. If the use of the vehicle at the time where they're using it is full price and then they later get the discount, as opposed to it's like discounted immediately, that can have a effect on the behavioral response to that price signal. Does that make sense?
Yeah.
So I actually don't know how the program necessarily works, but this is like a common issue that arises in implementation of things like this. Yeah. Do you know how that
So
program?
I'm not entirely sure. I know I'm in one of the counties. That's why
Okay.
I know about it.
Yeah.
But there is like a long, lengthy application, and it's similar to, I think, either PG&E or SCE. Like if you are already eligible for certain federal programs,
Yep.
like
It's some kind of like
food
care
stamps,
program,
right?
yeah.
And you just submit proof of that, then you get like a special discount.
Yeah. So even the time effect can have actually a pretty big change in the behavior. But yes, this is a common thing that you have to worry about is, okay, you have a policy, you try to design a policy to address issues like equity and how kind of fair it is. And that in itself may have some consequences as to like the efficacy of your policy. So you have to think carefully about its design. So this stuff is not easy, right? But I do think it's pretty important. Okay, who can tell me the difference between equity and environmental justice? Any ideas? Yeah.
Well, equity is just making sure that everything is balanced to each person's need. The environmental justice is trying to right the wrongs that have been impacted on.
Yes. Yeah, exactly. So I don't know if I entirely like this particular diagram for justice. I'm not sure if that does a good job at kind of describing this issue. But you're exactly right. So, environmental justice thinks about correcting systemic differences in populations who may have had like a history of inequities, and in this case, right, to address environmental justice, you may actually have equitable outcomes. Well, I shouldn't say non-equitable. It's you create fair outcomes for different groups, considering all of those past harms, which, in the absence of which, may not necessarily look like it's fair, right? But the idea is that justice creates this sort of long-term equity. Okay. Any questions about that? Yeah, and so, yeah, just keep this kind of definition in mind, and we're gonna revisit this in the space of a couple of sort of broader concepts that we've thought about before. All right, so just to give some folks some context in terms of sort of policy efforts at the federal level on environmental justice. So the first really kind of came about via this executive order 12898. So federal actions to address environmental justice in minority populations and low income populations. And this is kind of the first time in federal policy where we saw this idea that there should be a difference in the way that we're thinking about health and environmental outcomes as it relates to, right, like minority and low income populations. It required the development of a strategy to implement environmental justice, and it actively sort of promoted non-discrimination in federal programs. And as the years went on, there have been a couple of other sort of pushes for this. So in 1997, the White House CEQ issued guidance as part of the National Environmental Policy Act on thinking about addressing issues related to environmental justice. In 2010, interim guidance was given to, or given by the EPA to think about environmental justice when they developed new rules. And then most recently, has anyone heard of Justice 40? Okay, one person. So during the Biden administration, he issued this executive order kind of right at the start of his term, Executive Order 14008, which is, titled Tackling the Climate Crisis at Home and Abroad. And as part of that executive order, they established this initiative called Justice 40, which basically required any funding for federal programs have to, where you're benefiting specific communities, that 40% of those benefits have to go towards disadvantaged communities. And they had a whole criteria for this. Well, actually, different departments and made criteria for what constituted a disadvantaged community, and hence what would be covered in that 40%. And the White House eventually had their own sort of mapping that they use as guidance for other agencies. But yeah, so this was a big push to basically provide environmental justice in federal funding. that program doesn't exist anymore. Surprise, surprise. Okay, and no efforts on this thing in the most recent administration. Any questions? Yeah.
When was that first executive order passed?
Oh, the 12898. I want to say in the first Clinton, but I might be. Yeah, I'm not confident on that answer. It was Clinton. Yeah. Yes. Got it. Any other questions? Yeah, so I mean, 80s and the 80s and 90s, kind of where this movement really kind of took off, and so it wasn't until like the Clinton administration that we really saw any sort of action on this at the federal level. That being said, there are a number of things that states and local municipalities have taken in environmental justice. This is there's too much to sort of individually go through, but maybe this gives you, from a geographic sense, some idea of what's been done and by whom. Yeah.
What are bands on the red square?
Oh, yes. So bans might be prohibitions against certain types of activities. So maybe, let's say, oh, you're not allowed to operate like this type of industrial process or this type of I don't know, commercial facility if you're located within some distance of some kind of population group or something like that. Basically, prohibitions against some certain types of activities. Yeah.
Some of the cities seem to have two or more of the same color squares, so does that indicate that it's just two separate main policies?
Yes.
At the same time.
Uh,
Like San Francisco and I think that's Chicago. I can't sorry.
I think.
Los Angeles.
Yeah, LA has two
Oh, sorry,
green.
LA,
Yeah. They're probably in reference to different policies. Yeah. Yes, and Chicago has two red ones. Okay. Any other questions? So let's talk about climate, going back to kind of our sort of broader example. Yeah, actually, technically, you can change the color here. So so blue are countries who signed on to the climate accords. EU is a little different. It's like a region signing on to the accords. I guess technically the U.S. is yellow now because we left the accords in this current administration. So the idea is that signatories pledge to keep rise in mean global temperature below 2 degrees Celsius above pre-industrial levels, and preferably 1.5 degrees Celsius. So what does that mean in terms of, let's say all of these countries are committed to these general goals, and let's say that means we have to have some global target of emissions, and that amount has to reduce by some every year. So, who would be responsible for trying to achieve those mitigations? How would we do that? Any ideas? Yes.
So if it was an equitable way, then I guess the emitters should produce more.
Right. So basically, you're saying China should be responsible for about a third of the emissions reductions, and the U.S. should be responsible about 15-ish%, right? And we look at the annual share of these emissions, and that people can essentially follow that. What do you think China would say about this idea? Yeah.
They might create a lot of emissions, but the reason why they create a lot of emissions is because of the other countries or for the other countries.
Was what?
It's for the other countries.
Is
Because
for
they
the
produce a
other
lot of
countries.
Products of which they export.
Okay.
Buy.
And there are also many like richer countries that historically emitted much more, like the US, for example, also the European Union, and then countries like India just recently started emitting more. So they would probably argue, why should we now?
Yeah. So, cumulative emissions is the thing that actually causes climate change, right? It's not just the sort of annual emissions. And so China might argue, actually, we should only be responsible for 13%. Whereas, yeah, people might point to the US and say, no, you guys have emitted 25% of the total global emissions, and so you should be responsible for a quarter. Right? And even digging a little bit deeper, some people emit a lot more than others, right? So from a per capita basis, for example, if you look at the US, the amount that an individual person emits is maybe substantially higher, right, than someone else. And so you can think of this in different, you can kind of slice and dice this many different ways to think about what a country should be responsible for. And that is, something that, even during the sort of climate talks and the formation of the Paris Accords, and actually this continues to today, discussions of the responsibility of countries on mitigating climate change continues to be kind of a debated topic, throughout these sort of like climate conventions. Okay, any questions about any of this? Yeah.
As you just mentioned that the emission per capita,
Yeah.
the individual average. So do you think that it would be kind of to achieve equity, because that is for this data, like U.S. generates much more higher than China.
Yeah.
So is that fair that if we require that set the same level for both like United States and China, would that be fair?
Well, I'm not arguing any of that. I'm mentioning arguments that countries make, right, to make themselves look more favorable or shift responsibility to other countries. And there's not necessarily a right or wrong answer. Like, should everyone be, is the goal to get everyone to the same emissions per capita? I don't know. I don't know if that necessarily makes sense, right? People, different populations have different economies, different demands for goods and services. I think this is one way of slicing it. that is maybe different from cumulative emissions, that might be different from annual emissions, that people point to as a reason why, oh, this country should do more and we should do less, something like that, right? So there isn't necessarily a right answer for how the responsibility should be. Yeah, it's pointing out this is a difficult problem. Yeah.
To confirm, these emissions are based on in-country emissions and doesn't account for, say, whole industries being exported to cheaper locations.
Yeah, this is just in country. Yeah, yeah. That can be another argument.
And also argument was making for China because they do produce a lot of emissions, but a lot of the factories are located there.
Yeah.
For the rest of the world.
Yeah, yeah. Okay. There was a really kind of interesting paper in Nature which tried to look at this particular issue, and they generated kind of a set of different scenarios. Yeah, so this is in Nature Climate Change. And so let me kind of walk through these diagrams. Okay. So you have different ways of doing the allocation. So the allocation being who should be responsible for trying to do some amount of mitigation. Should it be based on capability, that is the resources of the country and how much they could ostensibly mitigate? Should it be equal on a per capita basis? Should it be based on greenhouse development rights? So this is like high mitigation for countries that have that are wealthier and have high per capita emissions. Should it be equal cumulative per capita? So should we mitigate based on countries with the highest historical per capita emissions, or CER, sort of constant emissions ratio? And this is the idea that whatever our current ratio of emission should be, everyone should just do that and continue on a mitigation path that makes sure that everyone's roughly in that same ratio. In the plot, you can see there's different countries: China, US, EU, India, and then this is the G8 plus China. So you'll see in each plot there is this dot NDC. That's essentially the target that was agreed to out of the Paris agreements. And then the different colors of the lines indicate the different sort of scenarios of mitigation that every country would be responsible for. So if we look at the US here, for example, we can see the NDC lies on this kind of brown line, which is the constant emissions ratio. It means that in the climate accords, the US is essentially able to say that the amount of emissions reduction that we should do should be just based on the ratio of what we emit now. But if you consider almost any of the other scenarios, if you look at the capability of the country, if we make it equal per capita, if we look at historical emissions, all of that would dictate actually the US should be doing a lot more mitigation out into the future compared to sort of baseline scenario, right? And you can see what that looks like for kind of everyone else as well. And actually, if you consider the position of the NDC dot relative to all of these other lines, usually we're seeing that the NDC is kind of at the high end in terms of the emissions allocation, but that inherently means that the rest of the world is like kind of picking up the slack here, right? Okay, any questions about this? Okay, why don't we take a quick break right now? We'll do 5 minutes and then we'll start thinking about some of these issues in some of our system models.
And the presentations are next week, right?
Yes.
When will you release when everyone presents? Or
Yeah,
can you choose?
there'll be a random assignment for when you guys present, either on Monday or Wednesday, and I will I'll have that. I'll announce that on Canvas.
And all the presentations are due on Monday.
Yes. right, let us continue on. So now we'll talk a little bit more specifically about philosophically thinking about integrating environmental justice and equity issues into models that we'll see some examples of this, and then how you guys might think about incorporating these ideas into work that you guys might be doing. So research in this area, so I'll mention, is across many different topical areas. It doesn't have to be just emissions. That's kind of the sort of default that I go to when thinking about some of these things. But in general, we think about equity and justice kind of informing design and formation of policy. You want to maintain efficiency and reduce unintended consequences, right? We've already talked a little bit about some of the unintended consequences that might arise either in the formation of a policy as it pertains to disadvantaged communities, as well as unintended consequences that you might have in your policy outcomes if you are even trying to address these issues, right? Okay, and so just to give kind of some examples, this was someone had gone through a bunch of different policies in California, thinking about how environmental justice applies to a variety of different topics, right? So, you know, we're mainly focused on this air quality idea, but there's a whole bunch of other issues that are covered by policies that, you know, don't even necessarily have to relate to energy. Questions? Okay. So if you guys will recall, this is the model framework for the times model, which is one of our sort of energy system model examples that we had looked at before. And so my question to you guys is, in a model like this, it doesn't have to be this exact one, right? But one that is looking sort of across different sectors and how the supply of energy and the demand of energy interact. In what ways is equity or environmental justice considered in this model? And how might this model be used to structure policies in certain ways that could affect outcomes that we care about in equity and environmental justice? So I'm actually gonna maybe give us a second to break apart again into small groups and you guys talk about this, and then we'll reconvene and see if you have any good ideas about the incorporation of these ideas into these systems models. So maybe get into groups of 3 or 4 and have a quick discussion.
There are multiple things you can do. One thing is to, for example, like for all the power generation and like all these things, like track with where, for example, power plants will open, that you can track it technically in your optimization if you make it a bit more complex, probably. And then another thing would be adding constraints, like that in maybe certain areas you can't open like certain power plants, like maybe in like disadvantaged areas you limit that from all.
That's all part of it.
Power plants you have, and so you can see how that affects the system based on energy design policy.
Which they never can have, but one way of doing it, I guess you could also
What are the
limiting energy resources or production methods.
Yeah. You're trying to determine where this shows up in the model and or how it can, how you can impact these things via the model.
Yeah. And I mean, another thing you can do also, like, again, with like constraint, like you can design, like, you could model like a policy in this way, for example, redistribute like certain like amounts of money, like maybe certain areas get like more budget to give them more capacity of certain things. That might be also cleaner if you add some constraints in terms of emissions or something. Because you can limit air pollution to a frequency constraint and see how that affects the system, and like maybe if the cost doesn't change, maybe that would form a good policy where you yeah.
The system, because, or at least I'm struggling to get this. Once you get to the demand side, there's so many choices
Yeah.
as a consumer, and I think it gets trickier in a cultural sense, a regional sense, and maybe a lifestyle choice type of thing. Like, for example, I'm looking at services like for light, cooking, refrigeration, like you only do it purchase only once every
Yeah.
maybe 30 years, maybe. And you don't always have like the perfect start, like at a nice baseline. Like you might not have the appliances that are most energy efficient. That's the worst thing to upgrade over time, but that's a choice.
Yeah.
I think those are like smaller maybe policies, but they have to be sensible to like with that kind of constraints that you were referring to, I was thinking like if you make it an incentive for people to buy more cleaner, like if, I don't know, you're getting coal from Vermont or you're getting coal from Portugal, like which one's cleaner? Why might be cleaner or even the service? Like there's that.
Yeah.
Environmental justice is justice applied to people or other living creatures?
Yeah, we usually think of this in terms of people. Yeah.
Well, here, for instance, like for EV charging, just different from perhaps one of the big problems allows you to kind of jump to the stage you can jump, like if it for like the public drinks.
Well, the problem to go with like modeling permanently and like optimization models is that optimization models always have perfect foresight. So you can, it's harder to include like permanently in timelines because the model already starts the process at the optimal time, so you don't really run into programming problems in like an optimization.
Oh, what I meant was like the timeline of approving permits for people that need them, like incentivize them to do this stuff that way they get it faster. Is that what you're referring to?
I guess like it doesn't have the specific one we're moving to, because ultimately like every place has permitting aspects which also would not necessarily have like a model. The average time.
All right. Let's reconvene, and I'm gonna kind of go around the room here. So, first group, what did you guys talk about in terms of identifying maybe equity or EJ issues in this scope?
Because some of them are kind of like, I don't know if it's necessarily issues, but it's just not outlined, but kind of putting some constraints around like the power generation module. I think it's broadly included on the left end of the diagram, saying that policies are included within kind of those
Sure.
technology prices.
But I guess my question would be, what what would you even want to measure in terms of like an equitable outcome?
I guess CO2 emissions is already there, but doing it regionally maybe would be
Okay.
something to benefit from. So like, I don't know if it would be in the entire scope of the model, or you'd have to apply the model to multiple regions and then test it out.
So I'm actually going to say that's the one area that you probably don't care about equity, in the sense that CO2 is not like a local pollution. It affects kind of everyone. But if you were talking about like local pollutants like SOx or NOx or something like that, then certainly yes, the like spatializing that as an environmental externality would be an outcome that you would care about coming out of here. To be generous, I guess you could say that the CO2 proxies for some of that, although that could be hit or miss depending on where this, like the source of the CO2. Okay, yeah.
Another thing you might be able to like measure is like the cost in certain regions. Like
Sure. Yep. So the cost of providing that service, instead of one generic cost for a technology to everyone in the population, maybe that's broken out, right, spatially or across some other slice. Anyone else talk about any issues as it relates to outcomes that you might measure? Yeah.
I would say noise is also something that's not
Yeah.
necessarily included.
Sure. And that was one of the like policy examples. Yep.
also reliability potentially like, of the grid, power supply.
Yeah. Okay. So those two things are are outcomes that yeah, aren't in the sort of default setting of times, but that perhaps you could elicit in some way. You for like noise, if you spatialize how this or where the supply is happening, and for reliability, I guess you. Can you expand what you mean by reliability?
I mean, I didn't think too much about it, but I guess maybe you could.
Because many of these services are, well, I'm thinking in like power generation, the reliability services are not going to be so locally constrained.
But for example, I know, for example, I think in the US and Puerto Rico, there's like a lot of reliability issues. I'm sure you could like they have probably like a separate, they have a separate grid, so you could like.
Yeah.
monitor,
Okay.
like,
Yes.
in different grid regions, you might have like different. I don't know, maybe
Yes.
forest and more factors.
Yeah. Puerto Rico, I guess, would be an example of this. Generally, the regions covered by the grid are too large to allocate reliability to like spatial regions, because it's basically the West US, the East US, and Texas is the way that our grid is kind of split up.
But maybe also in some other continents, like smaller countries or something that have their own grid.
Yeah. So maybe if this was like a larger times model that covers like a continent or something, then yeah.
Would resource availability be a constraint?
Resource availability. Yes, it could be for specific populations. If probably not for like electricity, but for other goods and services, that could be certainly.
I mean, like, if you're talking about hydropower, for example, it's not very prevalent here, but it's in Brazil.
Yes. Yeah. I mean, even in the U.S., there are divisions of power generation. So, like, the Pacific Northwest has a lot of hydro, but like California wouldn't. I mean, they have some amount of hydro, but not to the same extent. So yeah. And the question there would be about I think the relevance here is that there's an equity concern in terms of the locational restriction of fuel generation. It's not of the end supply, right? Because electricity everybody has, but it may affect the price of the electricity. And so backing out, really, we're talking about differences in prices that people get for their to receive goods and services. Yeah.
Kind of in the same vein of noise, like a spatial aspect of for air pollution based on like the local demographics or like disadvantaged community areas or something like that, or like in terms of like building the construction of new plants.
Okay, so we have sets of externalities, right, that we've talked about. So this is like local air pollutants. It could be noise. We have the prices of particular goods and services, if they differ amongst different regions in a model, that would be a different thing that you could identify. And then I would say probably the last one is the actual service demands, right? If those are restricted in some ways based on particular characteristics, right? Income, a location, that could be a piece that would come out of what you would see in sort of the demand side. Okay. What about levers to address equity and justice? And maybe I'll go around again. Do you guys have anything? What sorts of things might you implement to try and address issues of equity and environmental justice that might be able to be done by this model? And it could be for any of those items that I just mentioned. No ideas? What about in the back?
Price controls for energy demand services.
Okay. So you could, have some thresholds or constraints on prices that would then change this optimization so that if anyone faces a certain price, if a certain group faces a certain price, maybe it's not allowed. And that might shift costs to other populations, and you would hope to do that in an equitable way, or it would make this optimization infeasible, which hopefully that wouldn't be the case, but yeah. What about you guys in the back? Any ideas? What levers might you introduce into this model to address equity or environmental justice?
Yeah, we were mostly talking about like potential impacts and also how this chart is put together. I think we haven't touched upon like.
Okay. Were there any other impacts that you guys talked about that maybe I didn't address?
Like the location of fuel extraction.
Okay, the upstream impacts. Actually, yeah, that's a good one. Yeah, because this is mainly focused on supplying this demand and thinking about sort of the direct impacts, but actually a lot of these modules are flexible enough where you could do something like that. Upstream extraction, it would rescope some of the impacts coming directly out of the resources and potentials. Okay. Did you have a?
For the levers, I was thinking like a constraint that you could put into the model is a certain amount of fuel production or industrial sector is allowed in a specific geographical area.
Okay, so you put like spatial constraints on ability to supply certain things. Yeah, you certainly could do that. Yes.
Yeah, building on that, like you could have like air pollution constraints in certain areas, and then either see what like the effect of a policy that would have like a limit of air pollution and how much that would increase the cost, or you could direct investments based on what the model would do in response of this constraint.
Yeah, and that would emulate some kind of system like what we have in this country, in this state, where we have different air quality attainment areas that may have different types of constraints on pollution, and they could be a lot stricter if you are in like low income disadvantaged communities or disenfranchised communities. Yeah, so hopefully this is walking through this process is getting you guys to think a little bit about the relationship between the sort of framework of the model and maybe adding some of these particular issues. And so this in and of itself has been kind of an interesting topic amongst energy and transportation systems modelers. And so there's actually a really nice paper that was published in Joule a couple years ago by a really sort of fantastic set of authors. These guys are like all the who's who of people doing work in equity and environmental justice. Any sort of individual one of these people have contributed a huge amount to this sort of field of a study, and they kind of got together and wrote this paper that gives this sort of nice framework for how you would inject equity and justice into research on like clean energy transitions. And there's this figure that I kind of borrowed from their paper where they looked at sort of different little case studies and in the evaluation methods, things that you might want to think about as it relates to like equity and environmental justice. So we can walk through some of these. So residential solar adoption, what are available public finance mechanisms to subsidize solar adoption? And so how do we think about the costs and benefits of rooftop solar being distributed across ratepayers? And how can evidence of disparities in adoption inform solar incentive structures? This was maybe kind of well-timed to think about a lot of the arguments against the implementation of NEM 3. I don't know how many people are familiar with NEM. So a short and easy way of talking about this. So NEM stands for net energy metering. This is so when you guys consume electricity at your home, you pay some amount of money based on how much electricity you consume. If I add solar onto my rooftop, I can send electricity back to the grid, and the meter kind of runs in reverse, hence the sort of net metering. And if I send enough electricity, you could, in theory, kind of be positive. Okay, but that's kind of neither here nor there. The way that our electricity bills are structured is based on what's known as a volumetric rate. So I pay in proportion to the amount of electricity that I consume. So this is in contrast to a fixed rate where you would just pay a flat fee that irregardless of the amount of electricity that you consume. So the controversy about NEM is that not only are electricity generation is in a volumetric rate, but other fixed infrastructure is also in that volumetric rate. So like transmission and distribution infrastructure, all of like poles and wires, right, are included in that volumetric rate. And in net energy metering, you essentially produce a bunch of electricity and you pay not only for the generation of electricity, you pay a lot less for, you also pay a lot less for like all the transmission and distribution infrastructure that's in that volumetric rate, right? But the utility has to pay for that stuff. And so what ends up happening is that everyone else's rates go up because anyone who has solar pays less for that fixed infrastructure in their volumetric rates. So you can see this problem here, right? That anyone who has solar on their rooftop under older net energy metering rules, it means that everyone else in the system is subsidizing them and actually is driving the rates up for everyone else. And so net energy metering, the most recent one, NEM 3.0, which started a couple years ago, that was put into place to essentially reduce that impact. And so we might say, well, that's like a good thing, right? You're like shifting that cost burden from people who don't own solar to those that do. But actually, the costs and benefits of that distribution, like who are the people who first started owning solar? Yeah.
Mostly richer.
Yeah, wealthier people. And now that access to that resource is like more widely available, all of these people who'd been paying into that system to support these rich rooftop solar owners and now can finally afford it, now the rug is kind of pulled out from under them, right? And so that is, this, that's one of the sort of controversies about, I guess, fixing this issue. And so if you think about this idea from an equitable, just an equity perspective, right, then maybe NEM 3.0 is good because now everyone's paying their fair share. But from a justice perspective, you're like getting rid of a potential big incentive for people who have been, paying the consequences of that incentive for a long time. Okay, yeah.
And also now it's like harder to make it work because now you need like a battery so that you actually get.
Yeah, well, that's the whole point is that it's harder to make the case for it for the people who have been, who have had their rates going up because of it. Okay. Other issues, renewable energy siting. So defining these boundaries. Can municipal taxes be leveraged to attenuate burdens imposed by the project? And then what things that you might evaluate to think about equity and environmental justice. And then, importantly, the sort of metrics is like how you actually measure whether or not the particular evaluation is saying that it's good or bad in a certain way, right? And then you have a different one sort of for energy poverty alleviation. Yeah, so if you guys are like interested in this area and want to think more deeply about these issues and maybe injecting this into your research, I would recommend reading this paper. This is like this paper has been, yeah, kind of a quintessential framing of this of these
Might be more
issues.
technical, but how do you capture the metrics for the residential solar adoption example? If, I assume like all those costs are private information.
So you could think about it in aggregate too, right? You can think about how rates have gone up for everyone relative to what they were before you have this sort of policy. But yeah, I think so. Yeah, I guess I don't have an explicit slide on this, but metrics in and of themselves are one of the key ways in which we think about like success and failure in policies, which is why metrics are so important. So let me give you guys an example of this. So this is I did a little stint with the federal government a couple years ago to help out with implementing the NEVI program, which is a federal program to install a network of electric vehicle chargers. That program fell under the Justice 40 program, which means that 40% of the benefits of the program have to flow into disadvantaged communities. So let me ask you guys this question. This is the question that kind of I and a couple colleagues were faced with on the equity team. What would you measure to say that we are achieving Justice 40 in terms of like deploying charging stations? Yeah.
How accessible the chargers are to low-income households with an EV?
Okay. So as a metric, how would you measure something like that?
Low-income household EV energy demand served by the chargers?
Yeah, so
It's hard to measure.
yeah, it would be difficult to measure something like that because it's not like you're going around soliciting everyone's sort of income, right? So any other ideas? Yeah.
I guess just like how much or how many vehicles are charged or served in those low income areas, but then that's not proportional necessarily to that population. It
Yeah.
doesn't mean
So there were these siting plans where they would be like, we're gonna put these chargers in a disadvantaged community. It just happens to be like at this hotel that's like where people are passing through. It's not
Near
serving
freeway.
people. Yeah. Did I see a?
Well, you just pretty much.
Okay. Did you have any idea?
My question was, 40% of the benefits of the project or 40% of?
Yeah. 40% of the benefits of that project have to flow to a disadvantaged community. So I can tell you that certain higher ups in the government were like, yeah, okay, we'll say as long as the charger is in a disadvantaged community, then that counts as like a benefit for that community. And we were like, that's crazy. That doesn't mean that anyone in that community could necessarily benefit, right? So we came up with a whole slew of different metrics that you might kind of consider. Like if you develop this project in a particular area, are the developers some big national corporation, or is it like a local industry? Like what kind of workforce developments can happen in a particular area that we can prove comes from installing this stuff? Can we show how like retail services increase when you put chargers in particular locations and show that as like a benefit to the community? Yeah.
Could you maybe track DMV data to see like the registrations for that area where you
Yeah.
installed the?
Yeah, you should have been on our team. That could have been a good one, right? Yeah. So we would right. You can see that this program forcibly has this sort of Justice 40 requirement, right? But that the metric that you use to show that you're achieving Justice 40, right? If 40% of the charters are in disadvantaged communities, that means success, right? That could be really different than if you were measuring like, oh, what's the actual economic benefit to the place that we put the charter, right? So the metric really matters. It is, you can get by with some easy hand wavy thing that doesn't really make a difference, or you can like take the time to think about a metric that would make a difference, but that's also measurable, identifiable, verifiable, and implementable, right? So, anyways, a little bit of a tangent, but metrics are the sort of foundation in which you can like prove that you've done this. Yeah.
Does that paper talk about that?
Yeah.
So what ended up happening in your case? Was it the higher ups?
Not much. They didn't listen to us a lot. Or the equity team we were dismissed a lot. They have other things to, I'm not like necessarily defending them, but there's a lot. And also now that program is like on its last legs, I would say. But anyways, don't worry about that. We tried. Yeah, so thinking about the framework, I was kind of focusing on this idea, the last one, metrics, but other things, right? You want to actually determine the outcome that you want to measure. You want to scope the model appropriately, and then you want to be able to actually identify the discrepancies in those outcomes to the different populations. All right, any questions about this? Yeah.
Is it safe to say it's kind of difficult to incorporate VJ in terms of like maybe modeling in general?
It can be. Yeah, it depends on what you're trying to do, but it can be. But I think it's worth doing in many, many cases, right? Like we think about in the energy systems and like climate change systems world, for such a long time we were so focused on like efficiency and outcomes and like broader outcomes of just mitigation and reduction of emissions. I think that over time what happened is that people understand that okay, this stuff all needs to happen, and now we have to think about impacts of this transition. So that led to this bigger move towards equity and environmental justice. And it certainly makes things harder, right? Because now we have to care about before, where you think about populations as a whole, now you're breaking apart populations into like smaller groups. And you're thinking about finer spatial resolutions of things. All of these things make the models harder to run. It makes data harder to collect to address those things. But yeah, I think it's necessary. Okay, so let's look at a couple, we'll wrap up by looking at a couple examples, case studies of some of these things that have been looked at in energy systems. Okay, here, this is looking at distributed solar and environmental justice. So trends of electric vehicle adoption in California. So this is kind of like the sort of quantification of some of the things that I was mentioning with solar adoption relative to different communities. Okay. Has anyone heard of Cal EnviroScreen? Okay, a couple of people? Great. So CalEnviroscreen is a little tool that's put out by the state of California that helps to identify kind of percentiles of census tracts as it relates to a series of demographics and environmental exposures. So basically, if you are in the top 1% of the CES of CalEnviroscreen, that means you are like wealthy, affluent, and least exposed to pollution outcomes. And if you are a census tract down here in the 96th to 100th percentile, that means you're likely, a census tract with the lowest incomes, lowest education attainment. You have the highest environmental burdens and that sort of thing. So essentially, this is ranking all of the census tracts in California via these demographic factors combined with pollution exposure factors. And what they measure here is the amount of residential distributed solar that's installed, broken out by these percentiles. So if we randomly distributed solar panels to everybody, right, you would imagine that this is flat, but it's not. And in fact, it's extremely correlated, right, to both wealth and pollution exposure. So this is kind of a nice, very explicit look, right, at this idea of justice as it relates to residential solar adoption. And they have, the correlations of these things with a number of specific pollutant exposures or environmental externalities that are broken out more specifically from those percentiles as well. And you can see there that there are generally good correlations with some of these outcomes. So things like asthma, cardiac disease, low birth weight, ozone exposure, PM 2.5 exposure, and even traffic density. Okay, another one. This is a paper looking at environmental justice in heat-related health risks in Shanghai, and so they have a whole sort of systems modeling effect looking at heat exposure and how that is correlated to different classes of people and accessibility to cooling, right? And so heat exposure is kind of one thing, but the overlay of someone's ability to have air conditioning overlaid on that is kind of telling you or helping to answer this question of whether there's systemic risks related to demographic factors, right? And so that becomes an environmental justice issue, right? And so they looked at all of this, and basically you find pretty strong sort of correlations with accessibility to cooling, meaning that you likely have this sort of environmental justice issue happening here. Okay, I'll do one more example. This is a project that a former student of mine had worked on. So the idea is, let's say you have someone really rich in San Jose who buys a Tesla. They will improve the local air quality because essentially, let's say I've switched from, I don't know, like a Porsche to a Tesla or something. You've effectively removed an internal gas combustion engine off the road, which cleans the air in that area. But then when they charge, maybe there's some kind of fossil fuel plant, like a natural gas plant in Bakersfield, that will be providing the electricity that person is using when they're charging, which then reduces the local air quality of the region, of that region, right? And so you're shifting and causing environmental externalities in a different place. And so, yeah, this was something that we investigated. And so the net air quality, right? So when you switch to an electric car, in general, you're going to have big benefits in blue because you're removing cars off the road. But actually, in some places where you have fossil fuel generation, you may actually get worse outcomes. So this is an example of that. Okay, any questions about this? Yeah.
I was just curious, in the study, is there like an overall, like, net, like a net?
Well, yes. I mean, the net benefit, I mean, you can see that not only in our study, but in a number of studies, right? The like net benefit in reducing air quality damages is like very positive. But that's not the point of this paper, right? It's that you're shifting damages and making it worse in some places. Yeah.
I'm noticing that the contrast between like the intensity of the benefit and I guess the negative over time increases. Do you know what the reasoning might be?
Yes, because you have a lot more EVs that are charging a lot more, and so a power plant that's emitting is going to increase its production. Yeah. So, yeah, a little counterintuitive, right? And so what might this help inform if you were like a policymaker? Right? We say the policymaker is like, oh, we passed these incentives to get everyone to drive EVs and clean the air, right? Yeah.
I mean, I definitely, if I'm represented from the red spots, that would, I don't know, I would want.
Give me money or something, right?
Yeah, some kind of,
Yeah.
reparation.
Yeah, I was about to say like maybe you can use some like for example cap and trade funds in these regions to improve air quality through like investments.
Yeah. So you might want to have some incentives as reparations or increase funding to clean up some of these power plants.
Between 2040 and 2045, has some of the red dots disappeared? Is it because the benefits of the net benefits of the EVs outweigh the increased emissions by turning up the power plants, or?
Yeah, it could be, or the power plants are retiring in certain years. Yeah. Okay. The last thing that I'll say is that I think it is a great idea to consider some of this stuff in your research, but also as soon as you're walking in this kind of world of environmental justice, there are many complex elements facing these communities, and that this has happened before where you have like a researcher, come into the community and be like, oh, this is what you guys should do, blah, 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 right? That's not always a good idea. You may not be aware of the constraints that are surrounding particular communities, and oftentimes I would encourage that if you are interested in this type of research that you actually do talk with people and stakeholders that you're trying to model, right? That kind of engagement can help bridge the gap to avoid these sorts of issues. And I think it's an important aspect of this to kind of understand the real sort of constraints that, yeah, maybe you would have no idea to think about in your models. So, okay, we'll end there a little bit early today. And yeah, next class will be our last lecture before our final project presentations next week. I will post on Canvas the presentation order, which will be chosen at random. You guys are welcome to like talk to each other if you want to switch times. Just let me know. Otherwise, you're going to go in the order that's assigned. Okay.
Each presentation is 10 minutes.